The infinite money duplication glitch exploits the game's save system by manipulating server disconnections during transactions. Players initiate a purchase or sale while simultaneously forcing a connection timeout, causing the game to register both the transaction completion and the rollback state. This creates a duplicate entry in the player's inventory or currency balance, allowing them to profit repeatedly without consequences. To execute this glitch, players must time their actions precisely with server lag spikes, or intentionally disconnect their internet connection at the exact moment a transaction processes. The game's anti-cheat system struggles to detect this because it appears as a legitimate network interruption rather than deliberate manipulation, making it especially difficult to flag or trace reliably. The glitch works because the game saves player data in multiple stages. When a transaction occurs, the server first deducts the cost, then adds the item, then saves the new state. If disconnection happens between deduction and addition, the player keeps their original money while the server believes the transaction completed. Upon reconnection, the game attempts to reconcile the conflicting data states, often defaulting to the more favorable player state to prevent legitimate progress loss and avoid punishing users for technical faults. This exploit is particularly effective with high-value items or large currency transactions. Players often target premium seeds, rare tools, or bulk purchases to maximize the duplication effect. The glitch has evolved through multiple game updates, with players developing increasingly sophisticated timing methods, automation tricks, and connection manipulation techniques. Game developers have implemented several countermeasures, including transaction verification systems and rollback detection, but determined players continue finding workarounds. The glitch remains one of the most consistently reported exploits in the game's community forums, and a major challenge for long-term economic balance. Plant growth speed manipulation exploits the game's time calculation system by altering device clock settings or exploiting server-client time synchronization weaknesses. This glitch allows players to accelerate crop maturation far beyond intended rates, essentially fast-forwarding plant development cycles and skipping natural progression curves. The primary method involves adjusting system time settings while the game runs in background mode. When players change their device clock forward by hours or days, then return to the game, the growth calculations often use the manipulated timestamp rather than server time. This tricks the game into believing significant time has passed, instantly maturing crops that normally require extended waiting periods and resource planning. Advanced variations of this glitch involve time zone manipulation, where players rapidly switch between different time zone settings to create temporal inconsistencies in the game's timer system. Some players coordinate with others in different geographical locations to exploit genuine time zone differences, sharing accounts to maintain continuous growth acceleration across multiple time zones. Others combine this with local storage edits to amplify the effect even more. The glitch also works through forced synchronization errors by intentionally creating network instability during critical growth checkpoints. When the game struggles to verify accurate timestamps due to connection issues, it defaults to client-side time calculations, which players can manipulate more easily, especially on older devices or less secure network setups. Server-side implementations have attempted to patch this exploit by implementing stricter time verification protocols and mandatory server synchronization. However, the fundamental challenge remains that the game must balance offline progression features with anti-cheat measures. Players who understand the underlying time calculation mechanics continue developing new methods to exploit timing inconsistencies, often combining multiple tricks to bypass recent fixes. This makes plant growth manipulation one of the most persistent and creatively evolving categories of glitches in the farming simulation genre. Inventory overflow corruption occurs when players exceed the game's intended storage limits through rapid item acquisition or stacking exploits. This glitch corrupts the inventory data structure, causing items to duplicate, disappear, or transform into different objects entirely. The glitch manifests when players rapidly collect items that push their inventory count beyond programmed boundaries. The game's inventory system uses fixed array sizes or limited data structures that cannot properly handle excessive item quantities. When these limits are exceeded, the system experiences buffer overflow conditions, corrupting adjacent memory locations where other inventory items are stored. Players trigger this glitch by simultaneously harvesting multiple large crop yields, accepting numerous gifts, or rapidly purchasing items in bulk. The key is overwhelming the inventory management system faster than it can process and validate each addition. During these overflow events, the game's error handling often fails catastrophically, leading to data corruption rather than graceful limit enforcement. Common manifestations include items appearing with impossible quantities, negative numbers, or extremely high values. rare items spontaneously appearing in inventories, or entire inventory sections becoming inaccessible. Some players report their common seeds transforming into premium variants or tools, upgrading to higher tiers without payment. The corruption can propagate beyond inventory systems, affecting player statistics, achievement progress, and even game progression markers. In severe cases, the corruption becomes permanent, requiring complete profile resets or administrative intervention to resolve. Developers have implemented various safeguards, including inventory validation checks, transaction limits, and graceful overflow handling. However, the complex interdependencies between inventory systems and other game mechanics make complete prevention challenging. Players continue discovering new trigger combinations that expose previously unknown overflow vulnerabilities in the system architecture. Weather control manipulation exploits the game's environmental system by interfering with weather pattern calculations and prediction algorithms. Players can force specific weather conditions to appear on command, dramatically altering crop growth rates, special event triggers, and resource availability. The glitch operates by manipulating the random number generation systems that determine weather patterns. Players discover specific timing windows or input sequences that allow them to influence or predict the pseudo-random weather selection process. This typically involves performing certain actions during weather transition periods or exploiting predictable patterns in the game's random number seed generation. Advanced techniques involve coordinating multiple actions simultaneously to create specific input conditions that bias weather selection toward desired outcomes. Players might rapidly plant and harvest specific crop combinations, use particular tools in predetermined sequences, or exploit timing relationships between different game systems to influence weather calculations. Some variations of this glitch involve exploiting server synchronization issues between weather systems and other game mechanics. When weather data fails to properly synchronize across different game systems, players can create inconsistent states where certain areas experience different weather conditions simultaneously, or where weather effects persist longer than intended. The most sophisticated applications involve chain manipulation, where players create cascading weather effects by precisely timing multiple weather triggers. This can result in extended periods of optimal growing conditions, continuous special weather events, or access to weather-exclusive items and bonuses far beyond normal availability. Weather manipulation significantly impacts game balance by allowing players to optimize growing conditions continuously, access rare weather-dependent resources on demand, and trigger special events at will. The economic implications are substantial, as weather-dependent items lose their scarcity value when players can generate optimal conditions artificially. Teleportation boundary breaking allows players to bypass intended movement restrictions and access normally unreachable areas of the game world. This glitch exploits weaknesses in collision detection systems and coordinate validation, enabling players to traverse through walls, barriers, and map boundaries. The primary method involves exploiting coordinate overflow vulnerabilities during rapid movement or position updates. When players perform specific movement sequences near boundary edges, the game's position validation system can fail to properly constrain player coordinates within acceptable ranges. This results in players appearing beyond intended map boundaries or inside restricted areas. Corner clipping represents the most common technique, where players position themselves at precise angles between intersecting boundaries and perform specific movement combinations. The collision detection system struggles to resolve conflicting boundary constraints, often defaulting to allowing movement rather than blocking it completely. This creates temporary gaps in boundary enforcement that skilled players can exploit consistently. Network desynchronization techniques involve intentionally creating lag or packet loss during movement to confuse server-side position validation. When the client and server disagree about player position, the resolution process sometimes fails to enforce boundaries properly, allowing players to maintain positions that should be impossible. Advanced practitioners combine multiple techniques, using tools or game mechanics to enhance movement capabilities during boundary-breaking attempts. This might involve using specific items that modify movement parameters or exploiting interactions between different game systems that temporarily alter collision detection behavior. Successful boundary breaking grants access to developer areas, hidden content, unreleased features, and debugging tools that remain accessible in the live game environment. Players often discover unfinished content, test items, or administrative functions that provide significant advantages or reveal upcoming game updates before their official release. The Shop Purchase Rollback exploit allows players to acquire items from the in-game store while retaining their original currency through transaction manipulation. This glitch exploits vulnerabilities in the game's payment processing and inventory management systems during purchase completion. The exploit works by interrupting the purchase process at specific stages of transaction validation. When players initiate a purchase, the game follows a multi-step process: currency verification, item availability checking, currency deduction, item granting, and final state saving. By interfering with this sequence at precise moments, players can disrupt the normal transaction flow while still receiving purchased items. Connection manipulation represents the most reliable method, where players strategically disconnect their internet connection during critical transaction phases. The timing must be precise. Disconnecting too early cancels the purchase entirely, while disconnecting too late allows normal transaction completion. The optimal window typically occurs immediately after item, granting but before final state synchronization. Database rollback techniques exploit the game's data consistency mechanisms by forcing conflicting states that the system cannot properly resolve. Players might rapidly attempt multiple purchases simultaneously, or combine purchases with other actions that compete for the same data resources, creating race conditions that favor the player. Some variations involve exploiting client-server synchronization delays by performing local actions that the server hasn't yet validated. During high server load periods, the increased processing delays create larger windows of opportunity for successful exploitation. The economic impact of this exploit is substantial, as players can acquire premium items, rare seeds, and expensive tools without legitimate payment. This disrupts the intended game progression and creates unfair advantages over players following normal purchasing procedures. Developers continuously implement additional validation layers and transaction verification protocols to prevent successful exploitation. Crop mutation forcing allows players to artificially trigger rare plant mutations and genetic variations that normally occur through random chance. This glitch manipulates the underlying probability systems and genetic algorithms that govern plant breeding and evolution mechanics. The technique exploits weaknesses in the game's random number generation system by creating predictable conditions that bias mutation probability calculations. Players discover specific planting patterns, timing sequences, or environmental conditions that influence the pseudo-random processes governing mutation events. This involves understanding the game's internal probability seeding mechanisms and finding ways to manipulate input parameters. Selective breeding acceleration involves exploiting the game's genetic tracking systems by manipulating parent plant data during breeding processes. Players can force inheritance of specific traits or trigger mutations by carefully coordinating breeding attempts with other game actions that influence genetic calculations. This might involve simultaneous tool usage, environmental manipulation, or precise timing coordination with game update cycles. Advanced techniques involve exploiting storage and retrieval processes for plant genetic data. When plants are stored in inventories or transferred between different game areas, their genetic information sometimes becomes corrupted or accessible for manipulation. Players can exploit these transitions to modify mutation probabilities or directly alter genetic attributes. Some variations focus on exploiting interaction effects between different plant species or environmental factors. By creating specific combinations of plants, tools, and environmental conditions, players can trigger cascade effects that dramatically increase mutation rates or guarantee specific mutation outcomes. The implications for game progression are significant, as rare mutations often provide substantial advantages in terms of growth rates, yield quantities, or special abilities. Players who master mutation forcing can rapidly develop superior plant varieties that provide competitive advantages in both cooperative and competitive game modes. Multi-account synchronization abuse exploits the game's friend system and cooperative mechanics to transfer resources, items, and progress between multiple player accounts controlled by the same individual. This creates artificial multiplayer interactions that provide unfair advantages and resource accumulation. The primary technique involves creating multiple accounts and establishing friend connections to enable resource sharing through legitimate game mechanics. Players can then coordinate actions across accounts to rapidly transfer valuable items, currency, or progress achievements to a primary account. This might involve gift systems, trading mechanics, or cooperative farming features. Account cycling represents an advanced variation where players create numerous temporary accounts specifically to exploit new player bonuses, daily rewards, or limited-time promotional offers. These benefits are then transferred to the main account before the temporary accounts are abandoned. This allows indefinite exploitation of systems designed to provide one-time or limited benefits. Synchronization timing exploits involve coordinating actions across multiple accounts to create resource multiplication effects. For example, if multiple accounts can contribute to the same project or event simultaneously, players can artificially inflate their participation rewards or achievement progress by controlling all contributing accounts. Some techniques exploit server-side processing delays by performing coordinated actions across accounts that the server processes as independent events. even though they originate from the same player. This can result in multiple rewards for single actions or bypass limitations intended to prevent excessive resource accumulation. The competitive implications are substantial, as players using multiple accounts can achieve progress rates impossible through single-account play. This creates unfair advantages in leaderboards, competitive events, and community challenges. Additionally, the economic impact disrupts intended resource scarcity and progression balance, as artificial account networks can generate resources far beyond normal player capabilities. The Tool Durability Reset glitch allows players to restore worn-out farming tools to full durability without paying repair costs or purchasing replacements. This exploit manipulates the game's item state tracking system by creating conditions where durability values reset to maximum levels unexpectedly. The primary method involves exploiting save state inconsistencies during tool usage transitions. When players switch between different tools rapidly while performing actions, the game's durability tracking system can lose synchronization with the actual tool state. This creates opportunities to revert tools to previous durability values or reset them entirely to factory condition. Inventory manipulation techniques focus on exploiting the storage and retrieval processes for tools with damaged durability. By moving tools between different storage locations, inventories, or trading interfaces at specific moments, players can trigger data corruption that affects durability tracking. The game's error recovery systems often default to resetting corrupted durability values to maximum levels, rather than deleting the items entirely. Connection timing exploits involve using network interruptions during critical durability update processes. When tools lose durability through normal use, the game must save this updated state to persistent storage. By disconnecting at precise moments during this save process, players can prevent durability reduction from being permanently recorded while keeping the benefits of tool usage. Advanced variations involve exploiting interactions between durability systems and other game mechanics like achievements, quests, or special events. Certain game activities temporarily modify how durability calculations work, creating windows where the normal durability reduction rules don't apply properly. Players can exploit these special states to perform extensive tool usage without permanent durability loss. The economic impact is significant since high-quality tools represent major investments in the game's progression system. Players who master this glitch can maintain premium tools indefinitely without the intended ongoing costs. Quest completion bypass allows players to receive quest rewards without actually fulfilling the required objectives or conditions. This glitch exploits weaknesses in the game's quest tracking and validation systems by manipulating progress indicators and completion triggers. The technique operates by exploiting the separation between quest objective tracking and reward distribution systems. When these systems rely on different data sources or validation methods, players can create inconsistencies that result in reward distribution without proper objective completion. This often involves manipulating quest progress indicators through unintended interactions with other game systems. Progress spoofing represents the most common approach, where players artificially inflate quest progress metrics through repeated actions, data manipulation, or exploitation of counting errors in the tracking system. For example, if a quest requires harvesting 100 crops, players might find ways to make single harvests count multiple times, or manipulate the harvest counter directly. State transition exploits focus on manipulating the quest system during critical state changes, such as quest initiation, progress updates, or completion verification. By interfering with these transitions through connection manipulation, rapid input sequences, or timing exploits, players can force quests into completed states regardless of actual progress. Chain completion techniques involve exploiting dependencies between multiple quests or quest chains. By manipulating the completion status of prerequisite quests or exploiting inheritance relationships between related objectives, players can trigger completion cascades that award rewards for entire quest series. Some variations exploit client-server synchronization issues by maintaining different quest states on the client and server sides. When the game attempts to reconcile these conflicting states, the resolution process sometimes favors the client-side data, allowing players to force completion status on quests that aren't actually finished. The progression impact disrupts intended game pacing and reward distribution, allowing players to access advanced content and resources far earlier than designed. The Land Expansion Infinite glitch enables players to continuously expand their farming area beyond intended limits without paying the required currency or meeting expansion prerequisites. This exploit manipulates the land ownership verification system and expansion validation processes. The core technique involves exploiting the boundary detection system that determines available expansion areas. By manipulating player position data or exploiting coordinate validation weaknesses, players can convince the game that they own adjacent land plots that haven't been legitimately purchased. This allows expansion actions to succeed even when prerequisites aren't met. Purchase verification. Bypass methods focus on interrupting the validation process that confirms players have sufficient resources for land expansion. By creating timing inconsistencies between resource checking and expansion execution, players can complete expansions while retaining their original currency. This typically involves connection manipulation or rapid action sequences that overwhelm the validation system. Territory claiming exploits involve manipulating the land ownership database by creating conflicting ownership records or exploiting race conditions in the territory assignment process. When multiple land operations occur simultaneously, the system sometimes fails to properly validate ownership constraints, allowing unauthorized expansion into restricted areas. Coordinate overflow techniques exploit mathematical limitations in the land coordinate system by pushing expansion attempts beyond the intended numerical boundaries. When coordinate calculations overflow or wrap around, players can sometimes claim land in unexpected locations or bypass standard expansion progression requirements. Advanced applications involve chaining multiple expansion attempts to create cascading ownership effects. By carefully coordinating expansion timing and targeting, players can claim large territories in single operations or access premium land areas that normally require extensive progression achievements. The competitive implications are substantial since land availability directly affects farming capacity, resource generation, and overall game progression. Players with unlimited expansion capability can achieve production levels impossible through legitimate gameplay. Achievement unlock manipulation allows players to artificially trigger achievement completion and receive associated rewards without meeting the intended requirements. This glitch exploits vulnerabilities in the achievement tracking system and reward distribution mechanisms. The primary approach involves exploiting statistical tracking inconsistencies by manipulating the underlying counters and metrics that determine achievement progress. Achievement systems typically track cumulative statistics like crops harvested, money earned, or time played. By finding ways to artificially inflate these statistics through repeated actions, data corruption, or calculation errors, players can force achievements to unlock prematurely. Progress injection techniques focus on directly manipulating achievement progress data through inventory operations, trading interactions, or save file modifications. When achievement data gets processed during other game operations, there are opportunities to inject false progress values or manipulate the calculation algorithms to produce inflated results. Retroactive completion exploits involve manipulating historical data that achievements use for verification. Some achievements check player statistics retroactively when unlocking, creating opportunities to temporarily modify past activity records during the verification process. By carefully timing these modifications, players can meet achievement requirements artificially. Chain unlocking methods exploit dependencies between related achievements by manipulating prerequisite relationships. When achievements build upon each other or share common tracking systems, corrupting one achievement's data can cascade to related achievements, unlocking entire achievement trees simultaneously. Event-based achievement manipulation focuses on exploiting special events or temporary game modes that modify normal achievement tracking behavior. During these periods, the standard validation rules may be relaxed or altered, creating opportunities to complete achievements that would be impossible under normal circumstances. The reward implications are significant since achievements often provide exclusive items, substantial currency rewards, or access to special features. Players who master achievement manipulation can rapidly acquire resources and privileges that normally require extensive legitimate gameplay investment. The plant disease immunity exploit allows players to protect their crops from all disease effects and negative status conditions without using intended prevention methods or treatments. This glitch manipulates the disease application system and plant health calculations. The technique operates by exploiting the timing relationships between disease application and plant status updates. Disease systems typically apply effects during specific game cycles or trigger events. By manipulating plant states during these critical timing windows, players can prevent diseases from properly attaching to their crops or cause existing diseases to be removed without treatment. Status cleansing methods involve exploiting interactions between different plant management systems. When players perform certain actions like watering, fertilizing, or harvesting, the plant status update process sometimes corrupts or resets disease tracking data. By coordinating these actions precisely, players can force disease removal or prevent disease application entirely. Isolation exploits focus on manipulating the disease spread mechanics that determine how infections transfer between plants. By creating specific plant arrangements, boundary conditions, or timing sequences, players can create immune zones where disease effects cannot properly propagate. This effectively protects entire farming areas from any disease impact. treatment amplification techniques involve exploiting the disease cure mechanics to provide permanent immunity rather than temporary relief. When disease treatments are applied under specific conditions or combined with other actions, the immunity effects sometimes persist indefinitely instead of wearing off as intended. Advanced applications involve exploiting the underlying probability systems that determine disease occurrence rates. By manipulating environmental conditions, plant genetics, or random number generation states, players can reduce disease probability to zero or create conditions where diseases cannot successfully target their crops. The economic advantages are substantial since disease prevention and treatment represent significant ongoing costs in normal gameplay. Players with disease immunity can maintain optimal crop yields without the resource investment typically required for plant health management. Water system overflow manipulation exploits the game's irrigation and water management mechanics to provide unlimited water resources without proper infrastructure investment. This glitch bypasses normal water consumption limits and supply constraints. The primary technique involves exploiting the water calculation system by creating conditions where water usage doesn't properly decrease available supplies. This typically occurs through rapid consumption patterns that overwhelm the tracking system, or by exploiting timing inconsistencies between water application and supply reduction processes. Supply duplication methods focus on manipulating water storage and distribution systems. By exploiting the data transfer processes that move water between different storage containers or irrigation systems, players can create duplication effects where water quantities multiply rather than transfer. This involves precise timing coordination with storage operations. Infinite generation exploits target the water source mechanics that determine renewable water supply rates. By manipulating environmental conditions, weather interactions, or upgrade systems, players can force water generation rates to extreme levels or bypass the normal limitations on renewable water production. Distribution bypass techniques involve exploiting the irrigation system to provide water coverage without proper infrastructure investment. By manipulating pipe placement, coverage calculation, or water pressure systems, players can extend irrigation effects far beyond the intended reach of their water infrastructure. Advanced variations involve exploiting interactions between water systems and other game mechanics like weather, plant growth, or environmental effects. By creating specific combinations of conditions, players can trigger cascade effects that provide unlimited water availability or bypass normal consumption entirely. The progression impact is significant since water management represents a core resource constraint that shapes farming strategy and infrastructure development. Players with unlimited water access can pursue agricultural strategies impossible under normal resource limitations, disrupting intended game balance and economic systems. The seed rarity upgrade glitch allows players to artificially increase the rarity level of common seeds, transforming them into premium or legendary variants without legitimate acquisition methods. This exploit manipulates the seed classification and rarity tracking systems. The core technique involves exploiting data corruption during seed storage and retrieval processes. When seeds are moved between different storage locations, traded with other players, or processed through various game systems, their rarity metadata sometimes becomes corrupted or accessible for manipulation. By timing these operations precisely, players can force rarity upgrades during data transfer processes. Breeding manipulation methods focus on exploiting the genetic inheritance systems that determine offspring seed characteristics. By manipulating parent seed data during breeding operations or exploiting calculation errors in genetic combination algorithms, players can force the generation of seeds with higher rarity classifications than their parent genetics would normally allow. Classification overflow techniques exploit the numerical systems used to track seed rarity levels. By pushing rarity values beyond intended boundaries through calculation, manipulation, or data corruption, players can cause rarity classifications to wrap around to higher levels, or access rarity tiers that aren't meant to be achievable through normal gameplay. Conversion exploits involve manipulating seed transformation processes that occur during planting, harvesting, or special events. Some game mechanics temporarily modify seed characteristics, creating opportunities to make permanent upgrades to rarity levels during these transformation windows. Advanced applications involve chaining multiple upgrade attempts to achieve exponential rarity increases. By carefully coordinating multiple upgrade techniques and timing them with specific game states, players can rapidly progress seeds through multiple rarity tiers in single operations. The economic disruption is substantial since seed rarity directly affects crop value, growth characteristics, and market prices. Players with unlimited access to high-rarity seeds can achieve production values that fundamentally alter the intended game economy and progression balance. Server instance migration abuse exploits the game's server switching and instance management systems to duplicate progress, bypass cooldowns, and access multiple server-specific benefits simultaneously. This technique manipulates how player data synchronizes across different server instances. The primary method involves exploiting the data synchronization delays that occur when players switch between different server instances. During migration, there's typically a window where player data exists in transitional states that can be manipulated to create beneficial inconsistencies. Players can exploit these transition periods to maintain progress on multiple servers simultaneously, or prevent negative changes from synchronizing properly. Progress duplication techniques focus on timing server switches to occur during critical progress updates or achievement completion events. By migrating servers at precise moments, players can cause progress to be recorded on multiple server instances, simultaneously effectively multiplying rewards and advancement rates. Cooldown bypass methods involve exploiting the server-specific nature of certain game timers and limitations. By switching to server instances where cooldown timers haven't started or have different states, players can bypass waiting periods for actions like daily rewards, special events, or resource generation cycles. Instant shopping exploits involve rapidly checking multiple server instances to find optimal conditions for various activities. Different servers may have different weather patterns, market prices, event states, or resource availability. Players can server hop to consistently access the most favorable conditions for any given activity. Advanced techniques involve coordinating activities across multiple server instances to create compound benefits. This might involve initiating long-term processes on multiple servers simultaneously, or exploiting server-specific events to access limited-time benefits repeatedly across different instances. The competitive impact disrupts intended game balance, since server migration abuse allows players to bypass fundamental limitations and constraints that normally regulate game progression and resource acquisition rates. NPC trading exploit manipulation allows players to manipulate computer-controlled merchant interactions to receive favorable trades, duplicate traded items, or bypass normal trading restrictions. This glitch exploits weaknesses in the AI trading logic and transaction validation systems. The primary technique involves exploiting the NPC decision-making algorithms by presenting trade offers that create logical inconsistencies or calculation errors in the merchant's evaluation system. NPCs typically use simplified algorithms to determine trade value and fairness, which can be manipulated through carefully crafted offer combinations that exploit edge cases in their programming. Dialogue interrupt methods focus on disrupting NPC conversation flows during critical trading moments. By timing specific actions or inputs during trade negotiations, players can cause NPCs to skip validation steps, repeat beneficial trades, or maintain favorable trading states longer than intended. This might involve connection manipulation or rapid input sequences during dialogue transitions. Inventory state manipulation exploits involve presenting trade offers while manipulating the player's inventory state in ways that confuse the NPC's validation systems. By rapidly adding or removing items during trade negotiations, players can create inconsistencies between what the NPC believes is available for trade and what actually exists in the player's inventory. Price calculation exploits target the algorithms NPCs use to determine item values and trade ratios. By exploiting mathematical limitations, overflow conditions, or edge cases in pricing calculations, players can force NPCs to offer trades that are significantly more favorable than intended, or bypass normal market value constraints. Advanced techniques involve chaining multiple trading interactions to create compound benefits. By carefully sequencing trades with multiple NPCs or exploiting refresh cycles in NPC inventory and pricing, players can create arbitrage opportunities that generate substantial profits through automated trading patterns. The economic disruption affects intended market balance, since NPC traders typically serve as baseline references for item values and trading ratios throughout the game economy. Building placement boundary bypass allows players to construct structures in locations that should be restricted, such as outside designated building areas, overlapping with existing structures, or in environmental zones where construction shouldn't be possible. This glitch exploits the collision detection and placement validation systems. The core technique involves manipulating the coordinate validation system that determines valid building locations. By exploiting precision errors in boundary calculations or timing placement attempts during specific game states, players can force buildings to appear in positions that should be rejected by normal validation processes. Overlap exploitation methods focus on bypassing the collision detection systems that prevent structures from occupying the same space. By manipulating building rotation, size parameters, or placement timing, players can create overlapping structures that provide combined benefits or access to otherwise impossible building configurations. Terrain clipping techniques involve exploiting interactions between building placement systems and environmental collision detection. By targeting specific terrain features, elevation changes, or environmental objects, players can force buildings to clip through or phase into terrain elements, creating structures that occupy normally inaccessible spaces. Grid system manipulation exploits involve understanding and bypassing the underlying grid systems that govern building placement. By exploiting coordinate rounding errors, grid alignment calculations, or placement snap mechanisms, players can achieve building positions that fall outside normal grid constraints. Advanced applications involve exploiting building placement during special game states like weather events, server transitions, or update processes. During these periods, normal placement validation may be relaxed or altered, creating opportunities for placement that would be impossible under standard conditions. The architectural advantages provide access to optimal building locations that offer superior resource generation, strategic positioning, or aesthetic possibilities unavailable through legitimate placement methods. Experience point multiplication. Glitch enables players to artificially amplify XP gains from normal activities, rapidly advancing through progression levels without proportional effort or time investment. This exploit manipulates the experience calculation and award systems. The primary method involves exploiting the timing relationships between XP-generating actions and the experience calculation processes. By performing multiple XP-generating activities simultaneously or in rapid succession, players can cause calculation errors that result in multiplied experience awards for single actions. Action stacking techniques focus on coordinating multiple different activities that each generate experience points, timing them to occur within the same calculation cycle. When the experience system processes multiple simultaneous XP sources, calculation errors sometimes result in compound multipliers rather than simple addition. Event exploitation methods target special events, bonus periods, or temporary multipliers that modify normal XP rates. By manipulating the timing or duration of these effects through connection manipulation or state exploitation, players can extend multiplier periods beyond their intended duration or stack multiple multiplier effects simultaneously. Database timing exploits involve manipulating the save processes that record experience gains to persistent storage. By interfering with these save operations through connection interruption or rapid action sequences, players can cause experience gains to be recorded multiple times while preventing the corresponding activity completion from being properly tracked. Progress rollback techniques exploit backup and recovery systems by forcing XP gains to be recorded while preventing the consumption of resources or completion of activities that generated the experience. This allows infinite repetition of high XP activities without the normal costs or limitations. Advanced applications involve identifying optimal XP generation activities and developing automated or semi-automated methods to exploit multiplication effects continuously. This can result in extremely rapid level progression that bypasses intended progression pacing and achievement requirements. Resource Node Regeneration Override is a high-impact exploit that allows players to force the instant respawn of harvested resource nodes, completely bypassing the intended cooldown or regeneration timers. This manipulation breaks the natural scarcity mechanics designed to balance resource availability, effectively creating infinite access to rare and valuable materials that would otherwise be limited. The core of this exploit lies in manipulating the game's regeneration timer system, particularly the timestamp data that tracks when each depleted node should reappear, by creating artificial inconsistencies in the system clock, exploiting discrepancies in server synchronization, or corrupting internal timing data. Players can force nodes to instantly regenerate. The result is uninterrupted harvesting, even in zones that should be exhausted. One popular method, known as location cycling, takes advantage of the game's spatial tracking system. Players move rapidly between zones or abuse loading transitions to either reset node states or re-enter versions of areas where the nodes are still intact. This bypasses the usual persistence of depletion status. State corruption exploits focus on damaging or overwriting the save data that records which nodes have been harvested. By timing save and load cycles, manipulating inventory triggers, or exploiting internal data transfers, players can trick the system into forgetting previous harvesting events, essentially resetting the nodes manually. Synchronization exploits involve disrupting the balance between server and client interpretations of node states. For instance, the client may show a node as depleted while the server still flags it as available, or the opposite. By exploiting this lag or desync, players can harvest nodes that technically shouldn't be there. Advanced users take this even further by developing efficient harvesting routes, mapping node behavior patterns, and timing their runs to align with known game update windows. Some even exploit overlapping mechanics across multiple resource systems to multiply the benefits of a single regeneration exploit. The overall economic impact is massive. Infinite access to valuable resources erodes the supply and demand balance that supports in-game trade, crafting, and progression. Entire player-driven markets can collapse when once scarce materials flood the economy, reducing the value of grinding and destabilizing long-term player engagement. If you liked this video, don't forget to subscribe, and you also might enjoy watching these. Thanks.